Okay, let's see why we are learning the reference angle. Here, the absolute value of trig function value of theta equals absolute value of trig function value of theta prime. So if I have an angle, for example, I have 135. Can you find its reference angle? Yes, I can find where is 135. It's here in the second quadrant. So the theta prime, the reference angle of 135 is 180 minus 135. That is 45. Then the meaning of this equation is any kind of trig function of 135. For example, sine 135. The absolute value of sine 135 equals the absolute value of sine of its reference angle, 45 degrees. Oh, they have the same absolute value. Do you know what is the sine 45? Yes, in previous lesson we have learned that the sine 45 is square root of 2 over 2. The absolute value of this number is still positive. So I can ignore the absolute value. That means sine 135, absolute value of sine 135 equals square root of 2 over 2. All right, let's see. If I have sine 45, and then I have sine negative 45. Do they have the same reference angle? And how about 135 and 225? Do they all have the same reference angle? Let's see if I draw a XY plane. So so 45 degree is here. This is 45. How about negative 45? So you can use the coterminal angle to find the positive angle, or you just find it on the XY plane. Oh, this is the clockwise rotation, and we can tell that the angle formed between the terminal side and x-axis is still 45 degrees. How about 135? 135 is in the second quadrant, is here. So the reference angle is 180 minus 135 is 45 degrees. How about 225? 225 is here in the third quadrant. Then the reference angle here is 225 minus 180 degrees. That is 45. Oh, all of these three angles, they have the reference angle 45. Then the absolute value of these sines functions, they are the same. So sine 45 is square root of 2 over 2. So if you have absolute value, it still is a positive solution. How about the sine negative 45? Okay, so the is equals this. So it's square root of 2 over 2. Then the sine 135 is square root of 2. So I mean the absolute value of this, square root 2 over 2. The absolute value of sine 225 is square root of 2 over 2. So how about I pull out one of them, sine negative 45 degrees. I know the absolute value is square root of 2 over 2. And where is negative 45 degrees? It is in the fourth quadrant, is here. In the fourth quadrant. Sine in fourth quadrant is positive or negative? A, S, T, C. In the fourth quadrant, sine is negative. Oh, that means it's negative solution. And I know that the absolute value is square root of 2 over 2. Then without the absolute value, I know it's negative of square root of 2 over 2. All right, let's see next example. How to find sine 225 degrees. So first, let's find where is the 225 degrees on the XY plane. So first I will draw a XY plane. And where is 2 to 5? First, second, or third, or fourth quadrant. So it should be in the third quadrant, because here's 90, here's 180, here's 270. It's between 180 and 270. So it's here. It's 2 to 5. All right. Can you find the reference angle of 2 to 5? Yes, we can. So the RF, so I put it here. The reference angle of 2 to 5 is 2 to 5 minus 180, because in the third quadrant, we subtract 180 degrees. This is 45 degrees. Oh, is that same? Yes. Okay, I repeated to do this again. So let's repeat. All right. If we have the reference angle, then the sine 2 to 5 equals, I know, equals sine 45 degrees, but I need to decide is positive or negative sign. They have the same absolute value. I mean, here and here, but without the absolute value sign, I need to decide is positive or negative value. All right. In the third quadrant, we have learned that A, S, T, C. So sign here and here, they are positive. In the third quadrant is negative. That means I can only keep the negative sign here. Let's put negative and sine 45. So I can prove that is negative square root of 2 over 2. All right, let's see next example. Use reference angle to find the tangent negative 2 to 5. I'd like to find where is negative 2 to 5 degrees. So this is a negative angle. I don't like this at negative. Let's find its coterminal angle. So we have learned that if I add one rotation, full rotation, I will not change the terminal side. That means let's find the coterminal angle of theta. Let's say theta is negative 2 to 5. So we can use negative 2 to 5 plus 360. What is that? So I can use my calculator, help me to find, or use my mind, my brain. So it's 5, 3 is 135. Hopefully there's no mistake. And it's in the second quadrant. In the second quadrant, how to find its reference angle theta prime. Theta prime in the second quadrant is 180 degrees minus 135 degrees. That is 45 again. So 45 again in the second quadrant. So I know that tangent negative 2 to 5 degrees must be equal positive or negative tangent 45 degrees. All right, that means because I know the absolute value of this equals absolute value of this, but I need to decide is positive or negative. Let's take away the absolute value. Okay, in the second quadrant, we have learned A, S, T, C. Second quadrant, tangent is positive or negative. Tangent in the second quadrant is negative. Tangent here is positive. So I will put a negative sign here. And what is tangent 45? It's 1. We talked about this last class. So please memorize the special angles trig functions. All right, we finished the example 2. How about next example? Number 3, example 3. Find the exact value of 6 trigonometric functions of 2, 10 degrees. So we need to find, first step, find where is 2, 10 degrees is in the third quadrant. And how to find its reference angle, theta prime. So reference angle in the third quadrant is use the angle theta to 10 minus 180 degrees. That's 30 degrees. And then we need to find what is sine to 10 degrees. I need to borrow the sine 30 and then put a positive or negative sign here. So sine ASTC is here. ASTC. Sine in the third quadrant is positive or negative. You see here only have the t. T means tangent. So that means sine is negative. Let's put a negative sign here. And then negative sine 30. Last class we have mentioned, no. Let's see. Okay, last class we mentioned about the special trig functions. So that's 1/2. So you need to carry the negative sign with you. All right, how about cosine 210? We need to see cosine 30 degrees because we know that reference angle is 30 degrees. We need to decide it's positive or negative cosine in the third quadrant. Of course, it's negative because only tangent is positive in the third quadrant. So I put a negative sign here. And then what is cosine 30? Is square root of 3 over 2. And how about tangent? Finally, to 10 degree. We got a positive solution. That's tangent 30 degree because in the third quadrant, tangent, they are all positive. So tangent 30 degrees is square root of 3 over 3. All right, we found three trig functions. How about their reciprocals? Their reciprocals, cosecant to 10. I just want to find the reciprocal of this is -2. And then secant to 10 degrees is find reciprocal of this. So negative, keep the negative, and 2 to the top, square root of 3, go to the bottom. And then rationalize this expression. Then I'm having -2 square root of 3 over 3. How about cotangent? Cotangent to 10 degrees equals 3 over square root of 3. Flip this one. And then I'm having, rationalize this, I'm having square root of 3. So let me clear this, make it clean. All right, we found all 6 trig functions. How about next one? So find all 6 trig functions for the angle theta equals 945. This is a huge angle. I'd like to find its coterminal angle, which is a smaller angle. I can find it easily in one full rotation. So I can subtract some rotations. So for example, I say coterminal of theta equals 945. How about we subtract 2 rotations? That's 2 times 360. That's 945 minus 720. That is 225. We got a lot of 225 in our examples. So where is the angle 225? Is in the third quadrant, is here. All right, how about the reference angle theta prime? We can use 225 because in the third quadrant, use 225 minus 180 degrees. That's 45 degrees. So if I have 45 degrees, I can find all the 6 trig functions. So how about sine 945? It must be equals positive or negative sine 45 degrees. I think I leave too much space here. So sine 45, positive or negative. So we put A as TC here. In the third quadrant, sine is negative, only tangent positive. So let's put a negative sign here. And what is sine 45? That is square root of 2 over 2. How about cosine? Cosine 945 degrees. It is cosine 45 positive or negative. Cosine in third quadrant is negative because only tangent positive. So we're having negative cosine 45 square root of 2 over 2. So do not forget your negative sign. How about tangent? 945 is tangent 45. Positive or negative? Positive because in the third quadrant is positive. Sine 45 is 1. Let's find the other three trig functions. So cosecant 945. I just need to flip this one. I'm having a negative 2 over square root of 2. Rationalize this, I can do this. Square root of 2, square root of 2. Then I'm having negative 2 square root of 2 over 2. That is negative square root of 2. So the solution is square root of 2. Let's make it clear. All right, how about next one? Secant 945 degrees. So I also flip this one, the same solution. So 2 goes to the top, 2 goes to the square root of 2 goes to the bottom. So I'm having negative square root of 2. And next one, cotangent 45 degrees. So cotangent in the third quadrant is also positive because is reciprocal of tangent. They have the same sign. And the reciprocal 1 is 1 over 1 is 1. So we are done on this example. How about next one? Find the exact value of each expression. Okay, so we need to find their reference angle. But before we find the reference angle, we don't like the negative angle. So let's find the positive angle. So its coterminal angle of theta equals negative 240 degrees plus 360. So that's 120 degrees. Oh, 120, where is it? We need to find my graph. It's in the second quadrant. So can you find the reference angle? Theta prime, if the coterminal or the angle is in the second quadrant. Yes, we do, we know. So we use 180 minus 120. That is 60 degrees. If there's no mistake on my computation. So if I have the reference angle, how about cosine negative 240 degrees? All right, it equals the absolute, they have the same absolute value with its reference angle, which is cosine 60 degree. Is positive or negatives? So A, S, T, C. In the second quadrant, cosine is negative. So I must put the negative sign here. And then what is cosine 60? That is 1/2. We can put negative 1/2 for the value of cosine negative 240 degrees. All right, let's see next one. So if I have next one, that's a huge angle. I don't like the huge angle. Let's find its coterminal angles. We can use 675 degrees minus, how many rotations do you think? I think it's only one rotation. Subtract 360. What is that? That's 5 degrees. 1 is 3. So 315. And then find find the reference angle theta. Where is 315? So 315 is in the fourth quadrant. If in the fourth quadrant, how to find its reference angle? How to find this? We use 360 degrees minus 315. That is 45 degrees. So this angle is 45 degrees. How about the tangent 675? They have the absolute value of this angle equals absolute value of tangent 45 of its reference angle. So it's positive or negative? ASTC. So tangent in the fourth quadrant is negative. Only cosine is positive. So I have negative tangent 45. This is -1. All right, let's keep on moving. Let's see question 6. Find all the value of theta if theta is in the interval between 0 and 360. Excuse me. Given cosine theta equals negative square root of 2 over 2. All right, let's see. If my cosine is negative, where is my cosine? So A, S, T, C. So 1 and 4 is not, because in the quadrant 1 and 4, they are positive for cosine, all kind of cosine. Oh, sorry. So cosine value, if the terminal side is in first and the fourth quadrant. That means my theta must be in the second or third quadrant. Then my I have cosine theta be a negative value. And what is these two value of theta from here to here, and then from here to here? If I can know its reference angle, I can find these two. Oh, no. I can find these two angles. So how to find its reference angle? Here and here. So I know that cosine 45 equals positive square root of 2 over 2. And then 45. Oh, that means 45 is a reference of theta because they all have the same absolute value. All right, that means theta reference angle is 45. 45 is the RF angle of theta. Okay, that means I can put the 45 as the reference angle of these two angles. That means theta in the second quadrant could be 180 minus this 45 degrees. Then I can find, oh, this is my theta. So what is that? This is 135 degrees. And how about another theta's value? In the third quadrant, we use 180 plus 45. Because from initial side to here is 180, then plus another 45. That is the angle of theta. So that's 225 degrees. So theta has two values. One is 135, another one is 225. All right, let's see next example. Example 7. Find all the value of theta if the theta is in the domain from 0 degree to 360. So in one full rotation. So right now it provides us tangent theta is negative square root of 3 over 3. Let's find where is tangent theta. Oh, sorry, where is theta? We have ASTC here. So if tangent is negative, it must be in the second and the fourth quadrant. So for example, I just make random angles here. So we have learned that some special angle like tangent 30 degrees equals square root of 3 over 3. Let's see. Oh, this value and this value, the absolute value, they are the same. Oh, that means the reference angle of theta is 30 degrees. So 30 degrees is the reference angle of theta. Oh, that means, for example, that means here must be the reference angle theta, 30, and here is the reference angle of theta 30. That means the theta could be in the second quadrant is 180 minus 30 is 150 degrees. How about another theta? in the fourth quadrant, it is 360 minus 30 degrees. That is 330 degrees. So theta has two values, 150 degrees and 330 degrees. All right, we're done. We're done here. And the next video, we will learn the 2.3. All right, I hope you have a good day. And let me know if you have any questions. Bye, have a good day.